Anyone in Calc 3? Or past Calc 3? All right, so you've done multivariate calculus. I got a nod there, got some nods over there. My first year here, I went through and I did this triple integral, went through the whole thing, and then said, any questions? And somebody said, what was it you just did? None of them had gotten to Calc 3 yet to deal with that. So I learned that was beyond the scope. So we're going to try to get this in terms of a single variable. Well, R relates to sort of a position in space, and we have a relationship here between the charge and some position in space, so I can go ahead and make that substitution. It doesn't reduce a variable yet, but it sets us on our way. Q1. Actually, I'm just going to pull all the constants out front, so J hat, KE, and Q1, that's sort of popped out front, and I'm left with dQ2 over R squared cosine alpha. Is this a good one? Yeah. That's worse. So dq, I meant to make that substitution that time, so we'll do it now. So we got our constant here, so j hat KEQ1 sigma dA over r squared cosine alpha. Just to reduce the amount of writing I'm going to do, I'm just going to go ahead and we're not using the letter P for anything, so the letter P to equal j hat KEQ1. Actually, it's a vector. All right, so area. That's the area of this band of charge, this ring right here. Well, if I take any long strip, right, if I take actually any circle and I open it up, the area is going to be length times width. It's practically a rectangle. Well, the length is just the circumference of this. So the question is, what is the radius of this circle here? Well, let me pose it to you. What is the radius of that circle? As you draw it. This is theta, this is alpha, this is big R, this is little r, and that is L. And I'm asking for this distance right here. Looking for a formula. And as a hint, it's a trig problem. I'm going to call it X. Being shy, or trig just not a strong area? Suppose I took that triangle, that's a right triangle right there. Suppose I took that triangle and I just rotated it. So that angle's theta, this is X, and that is R.
r cosine theta.
Or
R sine theta.
r sine theta. Been a long time? All right, so the radius of the circle is the radius of that circle is the radius of the sphere times the sine of this temporary angle here. So this is r sine of theta. So what is the circumference? Another flashback to the past.
2 pi r.
So again, imagine I've got this ring right here, and imagine if I took that ring off, snipped it, and then stretched it out, I basically have a really skinny rectangle. Skinnier than that. And this distance is just the circumference of that circle. So this is 2 pi times the radius, which is r sine theta. Now we just have to figure out that thickness. And we'll test out some of my drawing skills. I'm going to blow it up some so that I have a chance of drawing something reasonable. That is really not any bigger than that. Center somewhere around there. And I've got this ring. So just imagine this band. Now the band is infinitesimally thin. I've made it, expanded it just for the sake of drawing here. Remember that we define theta to be the angle from that central axis there. So that angle there is theta. So what is this angle right here?
D theta? D theta?
Yep. This is part of a circle. Again, I've got this big circle right there. I have an angle and I have an arc length, which is what I'm trying to find here. I know the distance from the center to the surface is big R, so this is just big R d theta. That is the width of my band. Goes back to arc length is equal to R times theta, classic radian stuff. I have circle here, arc length, S, R, and theta. If theta is in radians, S is equal to R theta. So flashback to the past. So my area, my infinitesimally small area, we'll still have sigma. My area then is my length, 2 pi big R sine theta, times my width, which is big R d theta. Which simplifies down into 2 pi sigma big R squared sine theta d theta. And so now let's plug in. So I got my P times sigma. Oh, we should have pulled sigma into that. We'll do that in a moment. Sigma times dA, which is 2 pi sigma R squared sine theta d theta over little r squared cosine alpha. What too many sigmas in there? All right, so we took it from 3 variables down to 3 variables. We're on a roll. So life becomes a little bit simpler now because we can connect these. And now's the chance to use one of our favorite laws. Law of cosines. Who remembers law of cosines? So in this particular triangle, what would little r squared equal?
I guess, my bad.
You sort of remember it?
I didn't know I got it written down, so I went over Monday, but.
No, okay.
It's like A times B, 2AB cosine. My bad, I'm
Yep.
sure enough.
You're in the general direction, you got part of it. Recognize, law of cosines is just the generalized form of the Pythagorean theorem. Pythagorean theorem, a squared plus b squared equals c squared. So it's gonna start out similar to that. It's r squared is equal to, well, L squared plus big R squared. Minus, and then we get into the second part of what Devon said, minus 2 big L, big R cosine of whatever angle is opposite R here, which is theta. For a right triangle, the hypotenuse is opposite a 90-degree angle, cosine of 90 degrees is 0, and so this last term drops out for a right triangle, and you have Pythagorean theorem. And if you didn't, then the math people have been lying to us. They still haven't figured out how to divide by 0. What's their problem? All right, all's well and good, except I've got sine theta in there and a cosine theta here. That seems to be an issue. So if I have a cosine theta, how can I find sine of theta? Let me take a moment just to make sure that I'm not doing this in the wrong order. I don't think it matters. Nope, I'm good. If you have cosine of theta, how do you get sine theta? It's a Calc 1 question. Just to keep. Say it?
1 over cosine theta,
No, that would get you
or sorry,
Secant.
that's secant, yeah.
wrong S.
Divide by sign or multiply by sign, I can't remember which one it is. I think it's divide by
Neither of
sign.
those. It's a calc problem, as a hint.
Is it one of the trig identities?
Not the where I'm going with this. There's a sine squared plus cosine squared equals 1, but that,
Yeah, that's not, yeah.
that, you're gonna throw a square root into this? I don't think so. Now, part of this is, I'm not trying to put you on the spot. Part of this is, I'm also feeling out where you guys are. All right, I'm gonna spoil it. Take a derivative.
Oh.
What is the derivative of cosine theta d theta?
Negative sine theta?
Negative sign, yeah. So I have this equation here, which should be true based upon my way I've defined everything, and I'm just gonna take a derivative of it. So this becomes 2r dr is equal to, well, L is a constant. It is the distance between the center of the sphere and where the object is, and so the derivative of L squared is 0. R squared, big R squared, that is the radius of this sphere. That is part of the problem, is we have a sphere of a certain radius. This is also constant for this problem, so that is 0. These are all constants. Big L, big R, both constants. And so we end up with, and hopefully this will work better, we end up with, oh, got it right here, plus 2 big L, big R sine theta, d theta. And sine theta, d theta is I have right there. I now have my theta in terms of R, and I've gotten rid of one of my variables. Woo! Let's see, what constants do I have here? About to add more to it. Oh, so let's actually solve for sine theta d theta. Sine theta d theta is going to be 2 little, actually the 2's cancel out. Little r d little r over big L big R. And so I've got P sigma 2 pi big R squared, little r dr over big L big R over little r squared, cosine alpha. We can get rid of stuff now. One of the big r's cancel out, and actually one of the little r's cancels out. And so now my constants are, so I'm going to let, I'm using Q for something, M is big P sigma 2 pi big R over L. All I'm doing is just pulling out the constants, just, I'm hoping it'll save some writing later. And so my differential of my force on the electric force on charge 1, we're down to big M as my constant times dr over r cosine of, that should be an alpha there, cosine alpha. And then do a quick check to make sure I didn't make a careless error. Doesn't look like it. I did not do the intermediate step of writing that down. But it looks simpler. Again, this M has a bunch of stuff bundled up into it. Probably should write off to the side here, just in case something gets erased. So I said that P was J at KEQ1, and M, the vector M was P sigma, no, not, yeah, P sigma 2 pi big R over L. All right, so now we have an equation here with 2 variables on the right-hand side, so we need to get rid of one of them. We need to somehow connect little r and alpha. And we do that with the law of cosines again. Except this time, instead of having theta in my equation, I'm going to have alpha in the equation. So I'm going to start out with the opposite side, big R squared equals, and then we'll plug in the law of cosines. And I need room. And hopefully if there's a mistake, I'm not erasing it for troubleshooting later. Feeling reasonable about up to there. So using law of cosines, what does big R squared equal?
So little r squared plus L squared minus 2LR cosine alpha.
Little r L times cosine of alpha. Yep.
Yeah.
So cosine of alpha equals what? No fancy math, just algebra. What does cosine alpha equal?
Big R over L? Am I in the backwards again?
So
R
big
squared,
R over L?
I don't know.
It is not.
R squared plus L squared minus two RL, or two RL over R squared.
Nope. Alright, so we're solving for this right here, so we need to start getting rid of the peripheral stuff. Basically the opposite of the order of operations, PEMDAS. We do the addition and subtraction first. The things that are tacked on by addition and subtraction, we get rid of those, we bring them over to the other side. So we got big R squared minus little r squared minus L squared. Now I need to get rid of this up front, which is negative 2 little r L. Questions about that, since people were silent? I'm hoping it makes you go, oh, yeah, of course, but potentially not. You know, there's always the dream and then there's reality, no matter what. So I now have an equation for cosine alpha, which I can then plug into here. I'm gonna rearrange it slightly, because I'm gonna put my r squared and my big L squared together, and I'm gonna make little r squared separate. I got this negative right here, let's simplify it some. So I got big R squared minus big L squared over negative 2RL, little r, big L, minus little r squared over negative 2 little RL. So this becomes big L squared minus big R squared over 2